By the late 1800s, the region we now know as Poland had been carved up and absorbed by the empires surrounding it. Under Russian, German, and Austro-Hungarian control, the idea of a free Polish nation had essentially disappeared from the map. Marie Curie, who was Polish by birth, never stopped feeling the weight of that loss. So when she and her husband Pierre identified a completely new chemical element, she chose its name without hesitation. She wanted the discovery itself to echo her homeland's struggle for independence. That is how the element came to be called polonium, the first element in history named explicitly for a political purpose. But the story becomes even more unsettling when its properties are considered. Polonium is one of the most intensely radioactive substances ever identified. A single gram carries enough destructive potential to end the lives of 50 million people. Around 160 grams could theoretically wipe out humanity. Unsurprisingly, the element has been tied to a series of mysterious incidents over the past century, including suspected assassinations, unexplained deaths, and even the case of a Russian operative who uncovered the details of his own poisoning. If polonium were the central theme of a thriller movie, it would hardly need embellishment. Its real history already reads as if it were written for the screen. Marie Curie and Pierre carried out their groundbreaking research in what would be barely recognizable as a laboratory by modern standards. In Paris, the space they worked in looked more like a storage shed than the birthplace of a scientific revolution. With little more than determination and crude equipment, they arranged for massive quantities of ore to be delivered so they could break it down themselves. While studying a mineral known as uraninite, or pitchblende, they noticed something strange. The raw ore emitted far more radiation than the amount of refined uranium extracted from it. This contradiction could only mean one thing: a hidden element was present. Convinced they were onto something extraordinary, they ordered even more ore, and people who believed in their work began sending wagon loads of material to their makeshift lab. Months of painstaking chemical separation followed. Eventually, through a process repeated countless times, they isolated a substance hundreds of times more radioactive than uranium. That substance became known as polonium. Of course, none of this came easily. The Curie team needed enormous amounts of raw ore because even a full ton of material yielded only about 1/10 of a milligram of polonium. In other words, extracting a single gram required almost unimaginable quantities. Despite that, their persistence eventually led to the identification of what we now call polonium-209. At the time, scientific instruments were primitive by modern standards, so they had no real sense of how lethal the radiation from their discovery actually was. In fact, for years, the dangers of radioactivity were not widely understood by anyone. Before diving into the strange incidents connected to this element, it helps to understand what polonium actually is. With an atomic number of 84 and an atomic mass of 209, its most famous isotope, polonium-210, has a half-life of just 138 days. The element can be found in soil and in the air, and tiny traces even appear naturally in the human body. Polonium-210 itself is created mainly through the decay of radium, which is produced by uranium, an element present in most rock formations across the planet. Interestingly, certain organisms absorb polonium more effectively than others. Lichens, those fungus-like growths found on tree bark and rocks, are particularly efficient at pulling it directly from the atmosphere. In northern regions where lichens are abundant, reindeer feed on them, and communities that depend on reindeer meat tend to carry slightly higher levels of polonium compared with the global average. Because of how difficult it is to extract and how little of it exists in nature, polonium is classified as an extremely rare element. Its scarcity is so extreme that refining it from uranium ore is economically impractical. The element's intense radioactivity and the limited number of practical uses for it further reduce the incentive for large-scale production. Despite its rarity, polonium does have a few specialized uses. One of the most notable is its role as a heat source in thermoelectric generators aboard satellites and certain space probes. Because polonium decays extremely rapidly, it releases an enormous amount of heat in a very short period of time. Even a single gram can climb to temperatures of around 500 degrees Celsius in a relatively brief window. That same property made polonium valuable during the early era of nuclear weapons development. Before major wartime research projects began, Isolating pure polonium was essentially impossible. Once scientists recognized what it could do, however, production ramped up and the element was paired with beryllium as the triggering mechanism for the first atomic bombs. Yet most people encounter polonium in a far more ordinary setting. Tobacco products, particularly cigarettes, contain trace amounts of radioactive polonium. Research published in 2011 revealed that cigarette manufacturers had been aware of this since the late 1950s, but had never disclosed it. Estimates suggest that out of every 1,000 deaths linked to smoking, more than 100 involve polonium as a contributing factor. It is true that polonium-210 is among the most toxic and radioactive substances known. Still, it is not especially dangerous unless it enters the body. The alpha particles it emits cannot penetrate the outer layer of human skin. But once even a minute quantity is inhaled, swallowed, or absorbed through damaged tissue, the situation becomes catastrophic. Polonium-210 attacks cells at the genetic level, destroying DNA directly because of the extraordinarily high-energy alpha radiation it emits. That emission is, of course, the very reason the substance is radioactive in the first place. With that foundation in mind, we can now turn to the historical cases and controversial events in which polonium has been suspected or confirmed to play a role. The first death believed to be linked directly to polonium is a tragic and rather ironic one. Many historians think that Irene Curie, the daughter of Marie Curie, may have been its earliest victim. In 1946, while working in her laboratory, a glass tube containing polonium exploded. Nearly a decade later, she died from leukemia, and a number of researchers argue that the radiation exposure from that accident was the underlying cause. Another high-profile case emerged decades later involving Yasser Arafat, the former leader of the Palestinian Authority. After his death, forensic examinations revealed unusually high levels of polonium-210 on his personal belongings. Although the evidence was inconclusive and the exact cause of death could not be definitively proven, some analysts suggested that heavy smoking might also have contributed to the elevated polonium readings on his clothing. But perhaps the most widely discussed incident is the poisoning of Alexander Litvinenko. Before examining how polonium factored into his death, it helps to understand the backdrop of his story, which reads almost like a thriller. Litvinenko was a former KGB officer who defected and sought protection in the United Kingdom. Once a trusted member of Russian intelligence circles, he became a vocal critic after publicly exposing alleged assassination plots in 2000. Following his break with the Russian government, he fled the country and eventually made his way to the United Kingdom with his family, where he reportedly received financial support from British intelligence agencies as part of an arrangement surrounding his asylum. From that point forward, he lived in London as a political refugee, continuing his criticism of the Kremlin while working with Western contacts. Given what we know about the KGB, and more specifically about Vladimir Putin's past, it's not surprising that Litvinenko's story did not end peacefully. On November 1st, 2006, he suddenly became ill and was rushed to the hospital. His condition deteriorated rapidly. Earlier that same day, he had met with two Russian associates, Dmitry Kovtun and Andrei Lugovoy, in the lobby of a hotel. While they talked, he drank a cup of tea offered by the two men. As soon as he remembered that detail, the doctors began testing for radioactive substances, and the results were alarming. Litvinenko's blood contained extraordinarily high levels of polonium-210. In a sense, he had solved his own murder before anyone else had the chance. He died on November 23rd, but not before making several statements. He directly accused Putin of ordering his assassination and insisted that he should be held accountable. Years of investigations that followed pointed strongly in the same direction, though no legal proceedings ever took place. There were also a few striking personal moments during those final days. Before his death, Litvinenko revealed that he had converted to Islam. When he told his father, the response was simply, "As long as you're not a communist." One of Litvinenko's last messages was directed at Putin, saying, "You may succeed in silencing one man, but the outcry from around the world will echo in your ears for the rest of your life." In many ways, that prediction still resonates today. The day after Litvinenko's death, Putin issued a brief public remark. It appears Litvinenko was no Lazarus. For context, Lazarus is the figure in the New Testament said to have been brought back to life by Jesus. Litvinenko's story has the structure of a political thriller, and it eventually inspired one. His life was adapted into a television series starring David Tennant, produced years after the events unfolded. Although this narrative drifted briefly into a historical detour, it ultimately circles back to the core subject. The Litvinenko case, along with several others, illustrates just how powerful and dangerous polonium truly is. Understanding these events gives us a clearer sense of what this element is and why it holds such a unique place in scientific and geopolitical history. If you found this story compelling, make sure to subscribe for more deep dive documentaries. New investigations, new mysteries, and new histories are on the way.